Activity 7. Determining the equation of a quadratic from its graph. This activity is part of Unit 3, Properties of Quadratic Relations. Determining the equation of a quadratic from its graph. Vertex form. In this activity, we will explore how to determine the equation of a parabola in the vertex form, y equals a times x minus h squared plus k, from its graph when the vertex coordinates h and k are displayed. And the scale allows you to read the coordinates of at least one other point. To write an equation in the vertex form, we need the values of a, h, and k. A, h, and k. If the coordinates of the vertex h, k can be determined by looking at the graph, then the stretch factor a can be calculated provided that we can read the coordinates of one more point, x and y, on the graph other than the vertex. Determining the equation of a quadratic from its graph. To determine the equation of a parabola, given the coordinates of the vertex h, k, and one other point, x, y, we follow these steps. First, we'll have a look at the parabola here. We'll be trying to determine the equation of the quadratic that is represented by this parabola. We can see that it has a vertex here at the coordinate 1, 3. The x value is 1 and the y value is 3 for this vertex. When we look down at the parabola here, we can see that it crosses this intersection where x is 2 and y is 1. So we'll use that point as well. So we have a vertex point and we have another point on the parabola. Our first step, we're going to use the equation in vertex form to substitute the observed values. So we're going to take these values here and substitute them into our vertex form equation. We have our vertex, which is our h and our k values. So that's 1 and 3. And we have another point, which will be our x and y values, which is 2 and 1. So here it is substituted into the equation. Our y is 1. First look at our h. Our h is 1. Our k is 3. And there it is. Our x is 2. And our y is 1. Our second step is to calculate the unknown value for solving the equation for a. We need to find out a, and so we're using these values for the vertex and for this other point to help us isolate and identify the value of a. So 1 equals a times 2 minus 1 squared plus 3. That's 1 equals a times 1 squared plus 3. 1 equals 1a plus 3. Therefore, 1 minus 3 is equal to a, and negative 2 is equal to a. So we've identified our a value. We know that the negative sign works because this is the parabola is open down. So it must be a negative a value. We can also look at it and say that it does look a little bit compressed in comparison to the y equals x squared parabola. So the 2 works. -2 seems to fit this parabola. You should always ask yourself, after calculating the a, whether or not that fits what you see in the graph. We now have a third step. We'll rewrite the equation substituting a, h, and k. Y equals a times x minus h squared plus k. We know our a is -2, or -2, our h is 1, and our k is 3. We'll substitute those in, and we're given the equation y equals -2 times x minus 1 squared plus 3. There's our a. Our h is 1, so here it is there. And our k is 3, and there you have it. So our equation is y equals -2 times x minus 1 squared plus 3. If you use the vertex of the known graph as the ordered pair x, y, and substitute it into the equation, you will not be able to find the value of a. Let's have a look. Notice 1 minus 1 turns into a 0, and 0 times a makes the a go away. Let's look at an example. Given the graph below, determine the equation of the parabola. Here it is. Here's the parabola. We can see that the vertex is located here. The coordinate -1, -2. Here's another point. We see that the parabola goes through the y-axis here, where x is equal to 0 and y is equal to 1.